When we discuss nuclear energy, often three risks are mentioned related to the use of nuclear energy. The risk of a nuclear accident, the risk of nuclear waste with long half-life, and the risk of proliferation of nuclear weapons. Nuclear safeguards focuses on this last aspect of nuclear non-proliferation. Let's look to what safeguards really is, why it has been established, where and how it is implemented, and the basic principles on which its implementation is based. Safeguards, security and safety are often confused and were in the past often treated separately. Presently, we use the 3S concept, safety, security and safeguards, to integrate them in a more holistic approach. Nuclear safety is the prevention of accidents in nuclear installations that have unintentional causes, like natural hazards, equipment malfunctioning, or human errors. An important aspect of nuclear safety is the mitigation of the consequences of such an accident. Nuclear security focuses on the prevention of intentional human acts, for instance, to sabotage a nuclear installation or steal nuclear material. Again, mitigation of the consequences of such acts are an important aspect. Nuclear safeguards are international inspections that verify that states do not manufacture nuclear weapons from nuclear material in their peaceful activities. The legal basis for international safeguards inspections are the Non-Proliferation Treaty, the additional protocol to the Non-Proliferation Treaty, and for the EU countries, the Euratom Treaty, which is part of the EC treaties. The Non-Proliferation Treaty and safeguards inspections were established at the end of the 60s of last century. This was due to the concern that more and more countries seemed to want to acquire nuclear technology for the manufacture of nuclear weapons. To distinguish between military and peaceful use of nuclear energy, the Non-Proliferation Treaty framework was created. Not only to prevent the horizontal spread of nuclear weapons, but also to facilitate the trade of peaceful nuclear technology. Safeguards inspections are conducted by the International Atomic Energy Agency in all states that are part of the Non-Proliferation Treaty and that possess nuclear material. All nuclear material in possession of a state is subject to nuclear inspections. Also, the design of nuclear installations is inspected. The purpose of these inspections is to verify that all these activities cannot be misused for military or undeclared purposes. Safeguards inspections in the framework of the additional protocol also look to indications that states conduct undeclared activities or produce undeclared nuclear material. How do we perform these safeguards inspections? For instance, with visual inspections, we verify ID numbers on nuclear fuel rods. With seals and cameras, we make sure that the time between two inspections, nuclear material has not been moved or touched. With measurements of radioactivity or mass, to verify that the material has not been changed or diverted. And with other types of measurement, like calorimetry, to measure whether the heat output of plutonium, for instance, remained the same. This quote comes from a document called INCIRC 153. This document describes the implementation of safeguards inspections in states. Important elements are timely detection, significant quantity, and risk of early detection. The timely detection concept is used to determine how often safeguards inspections should take place. For material that can be used directly in a nuclear weapon, like plutonium or high-enriched uranium, this timeliness criterion for timely detection is defined as 1 month. For less strategic materials, like low-enriched uranium, this is 1 year. The reason for this 1 year is that it will take quite some time to make weapon-usable material out of low-enriched uranium. Significant quantity determines how much material should be verified and how much material should be taken away in order to provoke an alarm. For plutonium, it is defined as 8 kilograms, while for highly enriched uranium, it is 25 kilograms. The probability to detect a diversion depends on the strategic value of the material. For high-enriched uranium and plutonium, the detection probability is high, like 90%, while for low-enriched uranium it is set on the level of 50%. The more often you inspect, the higher the detection probability will be. The general purpose of the safeguard system is, on the one hand, to deter a state from proliferating, and on the other hand, to provide assurance to the international community that all state parties behave in a responsible way. I hope that I have provided you with a first insight on what Safeguards is, and hope to see you again in one of the more extensive courses that we provide. Thank you.